Okay, so today we're going to go a little bit farther into geometry and talk about polygons, which we know are two-dimensional shapes that have line segments as their sides. Now, a special type of polygon is what we call a regular polygon. And a regular polygon is equilateral, which means that all of its sides have the same length, and also equiangular, which means all of its angles have the same measure. So this is what it means by regular. Now we got to know the different types of polygons. So you should know the names of the polygons, pentagon, hexagon, heptagon, and so on, and know how many sides each of those things means. So just as a quick review, pentagon means 5 sides, hexagon means 6, heptagon 7, and so on. You should know octagon means 8, that kind of thing. So when it says draw a regular hexagon means I'm going to have 6 sides, and all of those sides are going to be the same length. So here's a regular hexagon. And so it's telling me each side length is 4 centimeters. So they're all 4. If this one's 4, I can denote on my hexagon that all of those sides are the same length. Now, if I want to know the perimeter of this particular hexagon, well, I've got 6 sides, and they're each 4 centimeters long. So we can just multiply. 6 times 4 centimeters is going to give me a perimeter of 24 centimeters. All right, so polygons. A few different formulas for area, so we want to talk about that. The first type of polygon we want to talk about is the triangle, has 3 sides. And something we covered yesterday was that in a triangle, all of my angles add up to 180 degrees. This is something we want to keep in mind. To find the area of a triangle, we know the area of the triangle is 1/2 the base times the height. Okay, where what we want to keep in mind is that base and height must be perpendicular. So we can see in the picture over here on the left, this square is a little off, but it's saying that the base and the height, they make right angles. Okay, so this is always going to be the case for the base and the height in any polygon, not only in triangles. The next type of figure we want to talk about is the trapezoid. Trapezoid has exactly 1 pair of parallel sides. Those sides we call the bases. So these are called bases. And so it does have 2 of them, and they're different lengths. You can see in the picture here, one base and the other. Okay, they're parallel, and they have different lengths of their sides. So in order to find the area of a trapezoid, that's going to be the average of the bases times the height. So you can see the formula here, 1/2 the sum of the bases, that gives me the average, times the height. Next type of figure, quadrilaterals. We got a bunch of those. First one we're going to talk about is a parallelogram. So this is a quadrilateral with 2 sets of parallel sides, as opposed to the trapezoid, which only has 1. Okay. And some other important kind of key features of the parallelogram are that opposite angles are congruent, and opposite sides also are congruent. Okay, so equal in measure. Opposite angles are equal in measure, opposite sides are equal in length. And the area of a parallelogram is just base times height. Okay, and again, base and height should be perpendicular, make right angles with one another. A rectangle, you're probably pretty familiar with. A rectangle is a parallelogram, which is important to note because it means that it's got all of the properties of the regular parallelogram. So I still know that angles that are opposite are congruent, sides that are opposite one another are congruent. But the rectangle also has some extra features, which are that it has all 4 right angles, and the diagonals of the rectangle are equal in length. They're congruent to one another. Okay. And the rectangle, the area formula, just like the parallelogram, is going to be base times height. Okay. In a rhombus is also a parallelogram, so once again it has all of those same features, same properties, but the special thing about a rhombus is that each adjacent sides, pair of adjacent sides, so next to each other, those are congruent, and the diagonals are perpendicular. So adjacent sides are congruent, which means that 2 sides next to each other are congruent. And of course, we know it's a parallelogram, so sides opposite one another. So really, a rhombus has all 4 sides congruent. And diagonals are perpendicular, so if I were to draw in the diagonals in the rhombus, I would know that they make right angles with one another. And once again, just like the previous 2, the formula for the area is going to be the base times height. Our final polygon, special polygon we want to talk about is the square. Okay. A square is basically a rhombus and a rectangle combined, so it does have those 4 right angles, and it also has 4 equal sides. Okay. So the area formula, we could consider that to have the same area formula as before and say that it's base times height. But what we notice is that the base and the height are the same size. So very often we'll call this S meaning the length of a side, and if the base and the height are both S, then I can say that the area of a square specifically is going to be S squared, okay, the side squared. So we can use all of these different pieces of information in order to answer some questions. For example, in this parallelogram here, okay, so I've got some variables. I want to solve for the 2 different variables. So we'll start with x. Now x, I see, is representing these 2 sides, left and right here. And I know that they're opposite sides in a parallelogram, which means that they must be equal in length. So I can set up an equation to say that the length of the side on the left, 3 times x minus 6, is equal to the length of the side on the right, 2x plus 20. And we can solve this equation. So I'll distribute the 3, subtract 2x on both sides, and add 18. So x is going to be 38. Now I also want to know y, and y is the measure of one of these angles down here in the parallelogram. So in order to figure out the angle, now I see one angle that's in here already, this is 70 degrees, but y is not opposite the 70-degree angle, so it's not congruent. The way we're going to find the measure of y is to keep in mind that these sides that are opposite one another are parallel in the parallelogram. So they're parallel lines, and I can sort of extend this out here and look at the picture like we saw the picture the other day of parallel lines cut by a transversal. And what I see is that this angle y and 70 degrees, those are same side interior angles, which we know means that they're supplementary. So angle y and that 70 degrees have to add up to 180 degrees, which makes y 110. All right, so moving right along. Circles, not technically polygons because they don't have straight lines or line segments as their sides, but they are a 2-dimensional figure. We like to talk about them. So formulas, the area of a circle is pi r squared, and circumference, we can use one of 2 different formulas, depending on whether we have the diameter or the radius. So we can have pi times d or 2 pi times r. Those are my 2 formulas for circumference. Okay. And so it finds area and circumference of a circle with diameter 10 centimeters. So if I have a circle and the diameter of that circle is 10, well, we should know that the relationship between the diameter and the radius is exactly 1/2 of the diameter. So if the diameter is 10, then that makes the radius 5. So I'm looking for 2 things. I'm looking for area, which I know is pi r squared. So pi times 5 squared is going to give me 25 pi. And my units are centimeters, so area is going to be centimeters squared. So there's the area of that circle. And then to find the circumference, again, I can use either formula, 2 pi r or pi d. I think I'm going to use pi d this time because I do know the diameter. So pi times my diameter 10, so 10 pi is going to be the measure of the circumference, 10 pi centimeters. When we combine what I know about areas of polygons and areas of circles, then I can talk about these shaded region type problems. So I've got a big figure and I've got part of it shaded, and I want to know what the area of the shaded region is. So there's really no formula for this. We kind of have to figure out what's going on in each problem, but something we kind of want to keep in mind is that we can always subtract whatever is not shaded from the area of the whole figure. So for example, on this problem on the left, I've got a square, right, because my length and my width are both 14 inches, so this is a square. And so I can say, okay, well then the area of the whole square is going to be side squared, so 14 squared gives me 196, and that's going to be square inches. And then now the area that's not shaded, I have these 2 sort of semicircles, and actually if I imagine putting the 2 semicircles together, I would have a whole circle. So the area that's not shaded is one whole circle. Okay. Now I don't know how big the radius is just yet, but I do see that this is a diameter here, and that's 14 inches, which means that the radius must be 7. So the area of the circular figure inside is going to be pi times my radius squared, so 49 pi square inches. So to get the area of the shaded region, if I take the area of the whole square and remove the area of the circle, that's going to leave me the shaded area. Okay. So the area of the shaded is 196 minus 49 pi square inches. And there's my shaded area. Okay. In the second problem, my bigger figure is the circle. So I want to start with the area of a circle. But the problem that I've got here is that I don't actually know the length of the radius. It's not given to me. Okay? But what I do have is I have a right triangle here. And I know the other two sides of the right triangle. So if you remember right triangles, we know if we know two sides, we can find the third side using Pythagorean theorem, that a squared plus b squared equals c squared. So I've got 10 squared plus 24 squared is going to give me my diameter squared. Okay. And when we solve this particular problem, this is 576. So d squared is 676. And so it turns out, it turns out that my diameter is 26 units long. And so if the diameter is 26, then that makes the radius 13 units. So the area of the circle, now I do have my radius, is pi times that radius squared. So the area of the circle is going to be 169 pi square units. And the area of the triangle is going to be 1/2 the base times the height. Now, base and height, we said, are always going to be perpendicular, so I can use this 10 and 24. They are perpendicular. We can call those the base and the height. So I can say that this is 1/2 times the base, which is, we'll call that 10, times the height 24. And when I multiply that all together, I get 120 square inches. So again, the area of the shaded is the area of the whole figure of the circle, 169 pi, minus the area that's not shaded, that triangle, 120. And there's my shaded region. Okay, all right, here we go. All finished with another one. Good job, guys.